Welcome back to Learning Solidity. Now in today's tutorial I'm going to be looking at three areas of development within Solidity, and those are auditing, security and testing. Now this is kind of a little bit of a follow-on from our previous tutorials where we started looking at multi-signature wallets. Now I did mention that I would be looking at security and testing, potentially in sort of different aspects, but I'm actually going to sort of collaborate them together into this one tutorial. So auditing is kind of a hot topic at the moment. I've been asked a few times, especially even on the comments of the YouTube videos, like how do I get into auditing? How long is it going to take me to sort of get to a sufficient level where I can start charging for auditing and so forth? I mean, I see quite a lot of jobs knocking around for auditing at the moment. And it is kind of a big thing to get into. So obviously, if you're into the whole sort of Solidity aspects of things, auditing is kind of key. I mean, even if you take the whole sort of issue with the previous, well, obviously the parity multi-signature wallet, for instance, where like I think at the time $300 million worth of Ethereum is lost. God knows how much it is now. I'm not saying that wallet wasn't audited. I'm not saying it wasn't tested correctly. I'm just trying to highlight the fact that of the importance of testing thoroughly. Now, what we can do is we can take a few things from the mistakes that were essentially made there, where that wallet was did have a hole in it where someone was able to authorize themselves essentially without sort of consent of the creator of the wallet, which was kind of key. So kind of with this, what I've done is I've taken the multi-signature wallet that I developed previously, and I've made a few modifications to it. At first I actually thought I found a security vulnerability in it, but kind of more out of luck than anything, I found that this security vulnerability was halted by sort of a previous step. So as you can see with this contract at the moment, I've left a few comments throughout the contract to basically highlight things where I'd perceive as security vulnerabilities or bugs in essence. So all I've done is kind of just listed this with like minor changes which should create various flaws. So the first thing you can probably see that I've done is I've removed the owner of the contracts and left this purely in the hands of sort of group control and group ownership. So I've removed the individual owner. I've also removed the sort of valid owner check in the modifier. I've actually removed the isOwner modifier altogether because we don't need it. When you actually instantiate the contract, it actually sets the instantiator, or the creator of the contract, as one of the owners of the owner group. And throughout the contract, I've just obviously removed any reference to isOwner. Okay, so let's start by looking at that. Now, what would be sort of like the big thing that we know about this? And now I can imagine a lot of people say, well, that's fine. Using group ownership shouldn't be an issue because obviously if you wanted to get rid of the sort of the creator or the master owner, I couldn't see why that would be an issue. Well, the first thing that kind of comes into light around here, actually there's a second, I've just noticed that I've missed another security vulnerability here. This remove owner has no modifier to it. So therefore, anyone can come and remove owners. So for instance, if you were to instantiate this contract with the obviously the constructor, set yourself as an owner, if someone then came along, invoked this with your address, this contract would then now have no owners. And therefore, no one could do anything about it, because obviously to add an owner, you need to be a valid owner, and therefore to do any sort of withdrawing or transfers, you need to have that ownership. So there we go. There's the first big security flaw that I won't say a security flaw because it's not really a security flaw. It's just a massive sort of bug that would lose you obviously a considerable amount of Ethereum if you had it stored within this wallet. And I actually did that without even realizing. I was only supposed to comment out that line and add simply valid owner to it. So there we go. There's a great example, and that was purely by accident. So that's kind of the things that we really want to address today, to sort of overlook to make sure that we don't overlook those minor yet massively implicating issues. Because if obviously I wouldn't have noticed that and I'd have deployed this as a live contract, and someone had been using it, and then someone would have found that vulnerability and exploited it, there you go. You've just lost every bit of Ethereum you have. You could put your life savings in it and then lost it. So this is the key to testing. We don't want to leave this up to chance. We don't want to just assume that everything we write is correct. And this is kind of why I always finish a lot of the tutorials and videos I do saying, don't take what I've written at face value. You know, I do make a lot of mistakes, and it's not purposefully. That wasn't something I did purposefully. That was something by pure accident. So let's kind of start investigating that whole concept. Okay, now we've kind of already, well, let's just follow on from that. We've identified now there's an issue here. How would we go about to test that? Let's just assume that we don't know that's an issue and we want to test it to be an issue. So what we have here, obviously this is it's still in the whole sort of truffle framework. We have this sort of truffle testing framework, and also something I forgot to add in the last tutorial was in the deployed contracts I forgot to add the multi-sig wallet deployment. All that is a very simple little script, which obviously I think I did actually include it when I pushed it up to GitHub. If not, it will be in this one, and it's also a very simple script where you just need to state module.exports equals the function, well, it's kind of an anonymous function which could simply be changed to a little bit of lambda, and all we're doing is calling the deployer, deploying the multi-sig wallet, and that's it. That's all you need to do. Now, the reason that we use this kind of little deploy script as well, it allows us to use the deploy address or the deployed address down in a Solidity test. You can import the Solidity test, Solidity deployment to your tests. I can't remember the exact one off the top of my head, and then you can actually just reference this deployment directly. So if you want to test it directly deployed on the network, you can without actually obviously having to deploy it. Okay, so now we have our little multi-sig wallet test suite, or a little sort of testing script. What we can do is we can start writing some tests. Now, like I say, this is going to be our first area of focus. How would we test this? We can test it by first, let's just keep it super simple, and we want to just focus primarily on access control. And what do I mean by essentially access control? Access control is that we want to make sure that our modifiers are limiting who is accessing our function, shall we say. So we do this by basically trying to catch the exceptions being thrown. Now, this is done in it's quite a simple way. I don't feel like it's documented very well often in Truffle, and I think it's changed a few times in various iterations. This is how I essentially test for exceptions being thrown, or opcodes that basically revert the transaction. Okay, so the first thing that we're going to test first, we're going to test the add owner, because we want to make sure that that's working correctly. Now, it's probably worth noting as well that I actually have like a little suite of like accounts here that I can use, and these are just essentially Ethereum addresses. It's part of the accounts, and when obviously you kick up the Truffle RPC, you get an X amount of test accounts, which all have X amount of Ethereum bound to them, so you can use them quite freely. So to write a very simple test in Truffle, we do it very similar to, I think it's Jasmine. Oh, it's snowing again. And that is essentially, you write it in almost a very sort of English sense. So by that I mean, you start off with the function it. Now, the first parameter that's passed into it is a string defining what it should do, or it should pass. And then you pass in a callback function, or in this case I'm just going to chuck in some lambda, of what the actual conditions of it passing are. Okay, so let's just start with it should revert the transaction of add owner when an invalid, should we say invalid, when invalid address calls it. Now that might be a slightly bit elongated, but we'll kind of leave it for now. Obviously you can refine how you want to sort of describe your tests. It's up to you. I like to be very descriptive, because when you're actually doing tests and you're trying to write a very descriptive way of writing tests, you want to make it clear what the test is doing and what is it testing for. So we want it to revert the transaction when of add owner when invalid address calls it. Okay, so that's as black and white as it needs to be. So let's start with the basics. Now, we've already said that we need to access the artifact of multi-signature wallet. So on every case that you actually make a call within this sort of testing frame, you should always return the value. This kind of allows us to sort of like acknowledge when sort of things have failed and get the results of failures and so forth. So let's say return. Then we're going to call the multi-signature wallet. Then we're going to call deployed, because we want the already deployed instance of it. And then this is essentially very similar to the whole sort of promise context. we're going to state that we want to pass, again, this is a bit of lambda, because traditionally you would write function instance. Now that's the first value that's passed into that sort of function. Because I want to write it as lambda, essentially that can be converted to that, and we can do some testing essentially in here. But we kind of want to make a little bit of a chain event, because at the current state of affairs, we actually have a blank contract, which will only have one owner, which is the creator address here. Now, if you want to obviously make sure that you're testing things correctly, the creator address is always going to be the primary address, or the sort of address 0 is always going to be the creator address of the contract and what the migration scripts use. So that's always a key point to check if you ever want to just do a simple test like what I'm about to. So I want to return the instance dot add owner. Now I'm actually going to pass in the first owner address and the second parameter of any call, or the final parameter of any call, if it's an object like that. That's assumed as kind of like extra parameter, well, not sorry, extra parameters, conditions of the actual transaction call. So for instance, if you want to specify where the call was being made from, a gas limit and so forth, you can do it as part of that object. So in this case, I actually want to I want to specify who the call is coming from. So I want to state from, and I'm also going to state the external address, because that address should not be an owner of this contract, and therefore any calls should invoke the basically require to fail and also then revert the transaction. So that's kind of what I'm assuming will happen. Now the next thing we're going to do is call then, which like I said, it's kind of like a chain event, which if I'm correct is part of the whole sort of like is it part of promises? Kind of. I always throw myself off when I'm talking about promises within JavaScript. I understand obviously the basics of around promises. I was just confuse myself when doing this sort of context of using .then. Pretty sure it is, but I could be mistaken, so feel free to correct me. Okay, so we have a call now to add owner. We're trying to add this first owner from this address, so that should not allow us to do it. Now you will hit this or this then if that transaction works. So again, similar to the previous sort of call, except this time, because we're returning the this sort of call, it's actually essentially the transaction. Now I could call the transaction explicitly, which will allow me to have a bit more information about that by simply calling .call, which will then do it through that. But I'm just going to call it by that because I don't really need any information from the transaction. We're going to call that result, and then we're simply going to state a very simple lambda function again. In this case, we don't want to return anything. We just want to assert .fail. Now we want to assert .fail there because if this has been hit, then this works successfully. Now what it should do is just fail straight off the bat. So the fact that this has worked means it's failed our test condition. It's not reverted the transaction, and therefore it's worked correctly. So therefore we now want to have a catch. Now the reason we kind of use the catch here, I'm going to put the error in again, a little bit more lambda. Now the catch here will catch this failure, because this will throw kind of an exception up the chain, which will allow us to catch it here. And also if this fails, it will skip this and go straight down to here. So then we can basically verify that this has failed. Now because obviously both conditions will end up in this catch block, we need to assert that the result of the failure is not down to this. So to do this, we can simply state assert dot not equal, and then we want to say the error dot message is obviously not equal to assert.fail, because obviously we don't want it to equal this here. We just want it to fail because of whatever's happened in here. It's easy to explicitly say that this we're referencing this here because obviously we don't know if any changes on the Ethereum network might cause this to change. So we can now simply state that transaction was not reverted with an invalid address. Okay, And that's pretty much simply it. Now, we can now run that test. So if I now just throw open a sort of command line environment to this directory, run the truffle test, hopefully this will fail. I might have made a mistake in this. Let's just see if this works. Right, should revert the transaction of, and calls it multisig wallet dot, well, I spelled deployed wrong, it seems. Let's see. Usually has an O in it. Let's try it again. Now I'm hoping this should cause the test to pass, and we can actually validate this test that it actually passes by then passing it. There we go. So it passed correctly, which was exactly what we wanted. Ignore the warning for now. The warning was something that I added to actually kind of highlight something else. So if we kind of remove this, I can also show you how it will now call directly from the creator address if you don't pass a specific address to call from. Okay, so if I now call this again, now this test should fail because it will actually pass, therefore hit the failure event. Here we go. Expected assert.fail. Oh, here you go. Transaction was not reverted with an invalid address. Expected assert.fail to not equal assert.fail. And there we have it. So that's basically us seeing that this was hit, and therefore it didn't match our criteria, and therefore the test fails. Okay, so I can put that back because we have now checked to see that that has passed. We now know that no one invalid can call that. Now I'm going to do a little bit of copy and paste there, because all I'm going to do is now change this to remove owner. Now, it's also worthwhile noting that other things can cause a transaction to revert, but we don't actually have any other checks here. We simply have just assigning an owner to a value of 0, which is actually fine. So we're going to change that to remove owner. And I don't think I've mentioned it anywhere else. Nope, I have not. So now, if I make that call again, we should now have 2 tests that essentially do the same thing. Are basically just checking for permissions to be called. So once we've actually gone through our tests, we can now see that our second test is actually, did that save and run? That should have had 2 tests. Passing 1, failing 1. Oh no, wait, that is running 2 tests. Ignore me, I'm being an idiot. Okay, so this should revert the transaction of remove over when an invalid address calls it. So now we know that our second test for remove owner is not passing. So we now need to make the change to invalid owner. This is kind of, well, it's not, this isn't test-driven development, sorry. I was going to say it was, but it's completely not. As you wouldn't even have this code if it was test-driven development. So now we've actually made the change to the actual multi-signature wallet itself, which should actually enable both test criteria to pass. Okay, so now we have 2 passing tests. Okay, so obviously if you were auditing log, you would obviously leave a note. The owner validation was missing. Okay, so now we've corrected the fact that the owner validation was missing, and we've now added it. So now our tests pass. So no one outside of the owner can actually now basically modify the contract. The next thing that I actually wanted to highlight with doing this is the fact that you can actually remove all the owners as the owner. So for instance, if you accidentally removed yourself and you were the only owner, you've now just negated all the owners of this contract, and therefore now everything is stuck. So we now need to write another test. We now need to make sure that if we remove an owner or remove ourselves as sort of the key owner, that we can't, in essence. So let's write a test around that. So we actually need to make 2 calls here. So the first call will be remove owner, and this is going to be the creator address. And this time we actually want it to we just want to call directly. We want to remove owner, and then we'll do a second test to, actually let's add another condition here to then, let's just say result. Actually, it's a result. Just call it removed result. And then simply return instance dot add owner. So I want to be able to add the owner back in. And then if we run that test again, we don't want it to fail. And in fact, we can probably go ahead and get rid of that, and we can go ahead and get rid of that. So we only want to catch now. So we want to catch when one of these two fails. So we don't need a condition to throw a sort of like an exception if something fails. In this case, if we catch anything, we just simply want to assert a failure, and we want to state why. Transaction was reverted. The transaction was reverted by a creator call. Should not revert the transaction of owner modification by the creator. Okay, so now we're simply stating within our test that the creator of the contract should be able to add and remove an owner at any point. Now that's something you may or may not want, but I always want that to work. So in this case, we now have an error being thrown, and it's basically causing us to hit this sort of catch condition, and the transaction was now reverted. Okay, so we kind of have a little bit of a problem there. So let's go back to having the old sort of owner modification in place. So let's say there's an owner there. Let's say our owner is back here, and let's return the valid owner call. So hopefully that should now cause that test to pass, but that might not be enough. For instance, we want. Okay, that is being thrown, and if you're ever actually in the state that I am now, where I'm trying to figure out why that's being thrown, let's have a look at the error. So you can do a console.log on the specific error to see what's actually being returned. Okay, and now we should have a nice error message being popped up. Except we are... reference instance is not defined. Oh, there we go. Ah, I see what... yeah, I can see what I've done wrong there. So what I can do at this point is simply state something along the lines of var, because basically in this sort of scope of function call, there is no reference of instance because it's maintained within the scope of this one here. So if I'm correct, what I can do is simply state var multi-sig wallet instance. In fact, I should probably define that at a higher level, so I can add it to basically being access to the scope throughout. I actually want to change that to lowercase. So this down here, multi-sig wallet equals instance. I've come across this a few times. Let's just change both those calls to that. See, that's why it's a great way to be able to dump your errors and then simply call it again. Now hopefully that shouldn't have now granted access to the scope, and hopefully that should have passed. There we go. Now we have all three tests passing. So we're not reverting the transaction of the owner, so it should not revert the transaction of owner modification by the creator. So, or I should probably say the creator address. So the owner of the contract, or the creator of the contract, has master ownership of this contract at all times in essence. So obviously if you were doing an auditing, you'd essentially state something along the lines of set master contract owner, and then you probably obviously leave like a little blurb saying to do this I added this extra condition to the requirement. I added a variable to the actual multi-signature wallet that basically stated that the owner had to be defined in a different sort of context, so no other modification could be made. Now obviously in previous modifications I stated that the owner is the only one that could add and remove other owners, which you may or may not want, but obviously if you were doing auditing, you'd leave that as a suggestion. The owner should only have the ability to add and remove other owners, but again that's kind of part of the auditing sort of context. Okay, so now we have three tests to basically check to see if various things have access, have the correct access. You may want to check the other function calls as well. Because as you've noticed here, when I actually did this, this was the only thing that I was supposed to leave, the no owner check-in, which that meant there was no valid owner being checked when you were signing a transaction. What I also did as well was I removed all the conditions from here, which I highlighted in the previous tutorial, where saying that the owner was not applicable to sign this contract. Also, if the person who created the transaction was not applicable to sign the transaction, as well as one person could not sign a transaction more than once. A couple of other things I did actually add were things such as massive security vulnerabilities, as well as a little callback thing. Now, I don't know if this is possible anymore. And what I mean by this is it was kind of an old bug within Ethereum, and I think that was actually the reason for the hard fork. There was a large reason why this used to be a massive security vulnerability, and I'll do you a little demo of what that was. So let's create a new contract called callback contract. Okay, so in our primary contract, we're assuming that that anyone who sort of interacts or signs this transaction actually has a callback mechanism in place called notify. So let's just define our contract. Pragma Solidity 0.4.0, and inside our contract we're going to call it the callback contract. Actually, you should call it contract. And inside this, you can do one of kind of two things with this. You could either have the function notify that takes a unit, let's say in this case an amount. Make sure it's public, it's payable, and doesn't need to return anything. Okay, so what's so distinctive about this callback? The key thing is, actually, I also want to pass in the, we'll set the transaction ID as well here. Unit transaction ID. Right, it's key to note within Solidity that things don't change until the transaction is complete. Now, when you sign a contract, or call this signed contract, that is the start of a transaction. This call is still a call to the transaction. It's still part of that transaction. Now, if I'm correct, this was rectified, but it's probably worth noting that this would have still been an issue. So, for instance, if you signed a contract, let's say that we knew this was contract transaction equals 0, you'd call this, and then straight away you would call back, let's just assume we know the contract address, multi-sig wallet, and then whatever, let's just assume it's an address we know, and whatever, OXO. Alright, we'll just say it's that. And then we want to call sign transaction, and then pass in the transaction ID. Okay, so what's happening here is that this function call, or this used to be the case, and this is kind of why it's important not to use these call mechanisms anymore. I know that has been rectified if I'm correct, but it's probably worth highlighting this issue. So calling this signed transaction would then invoke this mechanism as part of that transaction. This would then call this transaction, call this function within this contract as part of the transaction, which in essence would call this transaction back again. Now, obviously, at this point, the transaction isn't complete. Therefore, the person who signed it originally still hasn't signed it. Therefore, it can then eligibly hit this again, which in essence will call this again. And the process, if I remember rightly, used to just loop and loop and loop and loop. Now, the problem there is the fact that we were calling this as well, the transaction2.transfer. So on every loop, it was transferring that amount over and over and over and over. So when you, for instance, wanted to transfer 1 Ethereum and there was 11 in the wallet, it would call it over and over and over and over again until the wallet was empty. And that was a massive security flaw of Ethereum. Now obviously there's a few more bits and pieces to this whole sort of concept, and that, if I'm correct, like I said, this has now been fixed. So we don't really have to factor it in too much for now. We just know that that was a key issue, and it's something that we should be mindful of. So for instance, in this case, instead of calling something like transaction.call and so forth, we would then have it in place as something like, obviously we define an interface for this. So multi-sig wallet, and then whatever, let's actually say multi-sig wallet, I don't know, sort of receiver, and then notify, and then xxxxx. Basically, this then makes it, if I'm correct, I can't remember if it was the call that detached it from the function, or this that actually encases it in as part of the transaction, and therefore which will invoke the Stack Overflow. In either way, I'm pretty sure it is the correct way. This has been resolved. If I remember rightly, if that wasn't called or couldn't be met, it failed straight away. Whereas if this didn't call, what it had to do then was call the function callback mechanism, which was something along those lines. So even if this wasn't defined and you called that function, it would still end up hitting the callback, the fallback function. So this could be used as a mass distributed way to sort of like modify, obviously manipulate various different callback mechanisms. But for now, like I say, I don't really want to go, I think I'll cut that there because I'm pretty sure that was resolved. It's just something to be mindful of when you're actually doing these sort of things. So if you were going to do that sort of callback way, wouldn't do it like that because it will obviously end up hitting the fallback mechanism, and I'd always make sure that you were going to call back in that sort of context, because obviously it has to match the criteria of the multi-sig wallet receiver, which then would require that notify to exist, and therefore if it didn't, it would fail. So for now, what I'm going to do is just chunk that out altogether, because I don't really like having those callback functions in place if it's not necessarily required. And because this is a multi-signature wallet, we're kind of assuming all the addresses are not sort of contracts. We should also check to see if a contract exists at that address as well before calling it. So that's something else to be mindful of. Okay, so the next thing that we kind of want to look at or want to test, I'm not going to go into all the testing aspects of this, is to test that. I was going to cover this, but the fact that I've already covered the check to see if it is actually a valid owner was already in place, I'm going to just rectify that straight away. So that's already been rectified. Now, one other thing that I actually want to test for, which is actually kind of tricky, because this, if I'm right, and what this does is creates an overflow. Every time that you call an array length minus minus, it will just reduce the value of the array. So for instance, let's just keep this in a very simple context rather than going into the true context. And I believe there's been quite a few examples of this. If you obviously have an array length of 1 and it's minus minus, it becomes 0. Then if you call it minus minus again, it becomes, or whatever the maximum amount of array is, which is probably not, obviously starting with 9s, it'll be whatever, and so forth. Let's just say it's a 32-bit number, so it'll be 2 billion, whatever. So therefore, all of a sudden, that you've reduced that array index counter from 0 to now this massive number. To be honest, you'll probably run out of gas before that finishes, because it's then got to create all those array indexes. But then you actually create an overflow issue where, if I'm correct, then your array index has now access to, or creates a pointer reference access to, a different storage variable, which then starts getting messy, because then you can access and modify different storage mechanisms, which is still, if I'm correct, an active vulnerability within Solidity. So we can put a test, actually we can do a test around this. because we want an exception to be thrown. Now, the reason that I've wrapped that in an if statement is because previously I had it simply like that. Now, that would have tried to call an array out of bounds, which will throw a revert transaction because it was creating an array out of bounds. It was trying to look up an array out of bounds index, therefore threw an exception, therefore was actually safe. So the fact that obviously I did that delete, obviously that array index was safe and therefore worked fine. So what you could do, and actually I think I actually put that in, is put that assert replace. So therefore if the element was found, then it would revert the transaction. I think I actually should have left that commented out. And I'm also going to leave that commented out for now as well, so we can actually test this. So basically we didn't need a valid transaction to delete a transaction, which was wrong. So let's create another test case. It should revert the transaction on an invalid transaction ID. It should revert the transaction, I probably should have said, of delete transaction on an invalid transaction ID. Yes, that's correct. Now let's create a lambda function and let's make a call down here. Okay, so let's do the same sort of thing again. This time we're not going to call, or we're not going to create a transaction. We're simply going to state return multi-sig wallet.deploy. Let's try and get it spelled right this time. Dot then instance. Let's make this a little bit lambda. Return instance dot delete transaction, because we know this is an invalid transaction. Let's just say 1 dot then we just want to again check to see if it fails. So then result is the lambda function, assert dot fail, and finally catch anything we need to down here. So catch any errors, and simply assert not equal error dot message assert dot fail, then transaction was not reverted with an invalid transaction ID passed. Okay, so even though we're calling it with the creator address, which is fine, and this is what I was saying before, you really should have a call to every single one of these functions with the invalid creator address, or invalid owner address, to verify the fact that none of these were sort of essentially, or none of these were vulnerable to being called outside the scope of people that you don't want to, or unauthorized users, should I say. But obviously, like I was saying as well, there's other reasons why these things can throw exceptions, like obviously this delete transaction. So obviously if you would have called a signed transaction while that was still commented out with an invalid transaction ID, there would have been various reasons why that would have failed before obviously sort of knowing that there was actually an issue with the invalid owner. So now we've created that scenario, let's see if we can get this thing to fail. Now hopefully this will, transaction was not reverted, okay, let's see, hopefully this should, did that save? No, probably didn't save. Hopefully this should fail now, hopefully. It might actually crash the tests, because when I was trying this on Remix before, there we go, that's actually worked for us. Yeah, Remix, when using the EVM, the sort of like the test EVM, this actually causes this to fail, because it actually will pretty much break the actual, it'll basically break your browser, because it'll just try and create this array index that's so huge, or this array that's so huge it will just crash it. So let's just see, can we see, I kind of want to see the length of what that pending transaction is after we call it. So let's just create a very quick function, get pending transaction length. Let's make this a public view, and returns a event. So let's just have a quick look at what this actual value is. Okay, so if I call the get pending transaction length, if I then go into I need to create a local variable as well. Var multi-SQL instance. Call instance. Because I'm just curious to see what it is. It's console.log and multi-SQL instance get pending transaction length. Now hopefully that should give us a very interesting length. Let's see what it says. Now obviously, regardless of the fact that no, it's still pending, bloody promises. Let's comment that out. Let's comment that out. Yep, this is definitely a promises, and we need to wait for our promise to return something, so we need another then. Let's call this length result, and then simply console.log length result. Okay, let's see what that is then. Now, hopefully, there we go. This has now got a ridiculous length, and it's basically created this very screwed up array for us now. And because it's kept within the storage engine, the pointer of the array is now going backwards on itself, which is now pointing to things, if I'm correct, outside the scope of the array, which in a lot of contexts in programming languages, this will be known as a buffer overflow. So we've now created a very kind of screwed up array. I don't know if this is distinctive to a statically typed array or specifically a dynamic array, but I know that this can be incredibly problematic. So that is always something that you need to obviously check for. Just invert all those, because we wanted to make sure that that was going to fail if we passed an invalid transaction, and in essence it hasn't. So therefore our test is a failure. Now we need to address this critically. Now we can do this in one of two ways, because if I put this in, because obviously it's creating a separate event which will throw a which will basically cause the transaction to revert, that's fine, but we should always do a check as well to basically ensure that nothing else is being called outside that scope as well. So let's just put our assertion back in place to make sure that that was also causing the transaction to revert if basically the element or the transaction ID wasn't fine. We can also do another check here to stop the need for the for loop of asserting that pending transaction.length is more than 0. So that'll cause it to fail as well. So that'll cause it to fail to make sure that there are pending transactions. That'll cause it to fail if the transaction ID is invalid, and obviously this will cause the transaction ID to fail. Actually, they're thinking that through. That's actually more of a valid one, this here, because if that's not found, it's just going to remove whatever transaction off the list anyway. So again, that was a little bit of a bug from the past one. So again, I'm actually even discovering new bugs now while writing these tests. This is why writing tests is so damn important. Okay, so the final thing that I want to test without trying to drag this on too long, I know people are probably like, this video is too long on testing, but I'm just trying to drill into the fact of how important this testing is. I found 2 bugs in my code already that I wouldn't have thought of, and there are probably more. Even though I did things like this last time to basically catch potential bugs out, I probably still reckon there is more inside this. So I will address this as the final sort of check. So what we need to do is that we need to actually get to the point where we can sign a valid transaction, and obviously we even need to add owners. So we can use this sort of like this promise chaining mechanism in place that allows us to do this. So let's just state a very simple one. It, and then again, should revert the transaction if the creator of a transaction, I should probably now creating the this is now getting confusing because I've called these events transactions as well. If the creator of a, let's call it pending action, tries to sign the transaction. Again, probably a little bit elongated, but it makes it clear what the actual test is trying to test for. So now we now need to do a few things. So let's just call, actually no, we don't need to add a signature. No, we don't need to add any owners for this. We can just simply test it with the actual creator address. You can also then obviously write tests around making sure that these things do pass correctly. So obviously you always want to test in two contexts. You want to test in a positive aspect where you have the expectation of things working, and you also want the negative testing aspect where you're testing for things where you know should fail. So let's now do the basics of return multi-sig wallet.deployed. Let's try and get through this as fast as possible. Then instance some lambda. Then multi-sig wallet instance is equal to instance. Now a couple of people might state that I've defined this in multiple places. Now it doesn't actually matter because it's encapsulated within the scope of this lambda function, so therefore it's only defined within there. Any call to it outside of that function would return in an undefined variable. So we've defined that. Now the first thing we actually want to do is say the multi-sig, or return the multi-sig wallet instance dot, and now we want to create a transaction. So we want to withdraw, and we want to withdraw an amount of, let's just say 100 weight, and then we simply want to state that then get the promise, and then we're going to need the first withdraw result, small lambda. Now within this set of lambda, we then need to return, I'm actually potentially missing something here because this won't be deployed with any we. Yes, that is a very valid point. Now off the top of my head, I can't actually remember the call I did to do this, but luckily I have a project on GitHub which should test for it. Let me just jump over to a separate project which actually has my documentation for this. Okay, so you're, I'm pretty sure it was in that one. New, it's in one of these. It was in tutorial 22 tests, and I'm pretty sure it was the crowd sale. Yes, okay, so I now know how to do it. Probably should have checked that before actually recording this. Okay, so to actually transfer, if you wanted to transfer, for instance, we to a contract, we simply state then. Let's do this. We actually need to move the instance down one, because the first thing we're going to do is we're actually going to add some we to this contract. So let's move that up here. Okay, the first thing we need to do is return. Let's just make sure 100% that this is correct. So hopefully return multi instance dot transfer, and then if I am correct, actually let's just create a sender function, because I actually know how to do this in another simple way. I'll have to look up quickly how to call the fallback function because I can't remember off the top of my head how to do it. I'm just going to call this send, I'm going to call this public, I'm going to make it payable, and I'm literally going to leave it as that. So now I can do send, I can close, and then if I'm correct I can then simply call this with a value and then pass it 3.2 and then pass it 1 ether. Now, I did do that as part of tutorial 22 when I was testing the crowd sale, and I couldn't remember off the top of my head how to do it outside that. So that's going to be the result of the send, make it easier, send result. So now the contract has we, which is kind of really important, because obviously when we did our withdraw, if I remember rightly, I did actually do a check, and yes, so the transfer to requires the actual address, the contract to have we. I could have commented that out, but I thought I'd do this properly. Then the next thing is to withdraw the result, which creates the transaction. Then in the multi-sig wallet instance, I then need to sign this sign the transaction. So sign transaction, and then pass in the transaction ID, which I know off the top of my head will be 0, because there's only going to be one transaction on this. Just a side note, if I created another transaction, it would then be 1, because the transactions do get incremented. So then from there, what I want to do is then, because I want to catch the result of this, sign result is going to be a failure event. So assert.fail, and then finally we need to catch that and do something about it. So error into some more lambda. Okie dokie. So inside that we need to then have an assert, create, let's see, just assert dot not equal is going to be error dot message is assert, it's not equal to assert dot fail, and transaction was not reverted after creator signed a transaction. I'm just going to leave that as is, probably not the best wording, but there we go. So we can simply run it. Hopefully that test will pass. I probably made a little bit of a mistake there somewhere, which if I did, I will correct promptly. So there should be now 5 tests. One of them should fail. Multi-sig wallet deployed. Let's see where I got that. Multi-sig wallet dot deployed. That's correct, isn't it? Whereabouts is that error? Oh, don't open Bitcoin wallet. I should have Bitcoin wallet. Multi-sig wallet dot deployed. Unexpected syntax. Did I miss something? No, that all looks correct to me. Return. Multi-sig wallet. It's definitely referring to the right one, is it? Oh no. It doesn't give me my own line, which is a pain in the ass. Oh, it does line 66, which is this line. So var multi-sig wallet. Let's try that again. Just make sure that definitely is that's causing the error. Come on, work. 10. Unexpected token. What? Let's just copy and paste this a second. Make sure I get it all right. Actually, let's copy and paste all this. Trying to see what the difference was. I left a semicolon broken something. Alright, no. That all looks fine to me. That's still failing. I'm probably like missing something blatantly obvious here. Why is that failing? Return the multi-sig wallet. Right, it should. Right, let's just start with the basics of finding out what the hell I'm doing wrong. Comment all that out. Does this pass? Yes or no? Right, so that's got 5 tests. Okay, so the first thing that I had was, let's try uncommenting bit at a time. Return. There we go, we've got our first error, so that didn't work. Okay, the multi-sig roll should revert the transaction. Error, big number, not number. What was not a number? So, send public variable value we. Why isn't that not working now? That should have worked. Work 3. Actually, we can probably cut that down to make this very simplified by just saying that we want 1,000 way being transferred, because we're only transferring 100 back. Big number error. New big number is not a number. Okay, so what was the error there? I don't know if I need to specify the from and then create an address there. And then call that. Or that can simply be called the transfer, maybe? Let's see. It's a big guessing game at the moment, because I don't have the documentation to hand, and I'd rather not read it and just quickly get through this. Come on, work. Yeah, there we go. It's not a function, god damn it. Let's just see if I can just hit the callback function with call. Let's find out very quickly. So the truffle documentation. How do I call the damn fallback function? Send transaction apparently. So send. Hopefully that will now allow me to hit the fallback function. Trigger the fallback function by sending transaction to instance.send transaction.then. There we go. Okay, we're past that part. I slowly get past all my scripts one at a time. Okay, let's see if that then worked. I probably left a bit of a hole somewhere. Let's see if I can comment all that. I need the semicolon there. Hopefully that should call my fallback function to fail. Yeah, sorry about that. Wasn't expecting that to crop up during this tutorial. Should have been a slightly bit more prepared. Okay, we still have a issue there. No, I just got to find out where it is. It's not there. It's not there. Send result. There it is. Okay, we resolved that error as well. That was a bit slightly annoying. I'd really wish I'd put that into the tutorial and would have resolved that beforehand, but there we go. Now hopefully that should now have passed. Nope, we now have a different error. It's the semicolon. Okay, so after all that, this should now fail. I hope so. There we go. Transaction reverted. Yes, okay. Right, so we've now got it to fail, which meant that we now needed a check in place to revert the transaction if the creator of a pending transaction tries to sign the transaction. So if the creator was from that, let's undo those. For some reason I'll need one comment. That should now pass because the creator of the pending transaction shouldn't be allowed to call it. Let's see, because that was a comment that didn't need to go in there. And for the final test, I'm going to rush through this very quickly with a very quick copy and paste. it should revert the transaction if the signer of a pending transaction tries to sign transaction again. So let's see, did that pass? Okay, all 5 passed there. We're on the 6th one now. Now we have to add a little bit more to it, so we added some we to the contract. What we need to do in this one is to then assign the second contract. We need to withdraw. We also need to add a little bit more logic then. Let's add this, the withdraw. I should just move this up because we now need to ensure that we added a second signer. So let's add the first owner signer, which in this case is now going to be a return. Let's just call that transfer result to an anonymous, to a lambda function. Return the multi-signature wallet instance dot add owner, and then we simply need to add the first owner address. Then we need to withdraw using the first owner address, so from with first owner address, sign it with the creator address, sign it a second time with the creator address, so first withdraw result, and then call that second withdraw result. Okay, on the second withdraw result, it should result in a failure. So let's just make sure, add result, and hopefully, if I am correct, that will fail because we will allow multiple signers to sign the contract because we don't have a check here. Then if we put the check back, why is that actually passing? That shouldn't have passed. Let's have a look here. Sign transaction 1, second sign transaction 2. That should have resulted in, if that worked, it should have resulted in a failure. It didn't, so there was a second error there. So console.log, let's see what the error was. I do apologize if this is a very elongated tutorial. This is just kind of the process that I'd go through if I was testing, auditing a contract, so I'm trying to give you the best insight possible. Okay, let's see, an invalid opcode has been triggered. Okay, so something else has failed here. So the wallet was withdrawn. Let's just test to see what point that actually was triggered. I've got the funny feeling it might have been done there. So let's just test that. Come on, let's see. Hopefully nothing should hit that. Okay, nothing did hit it, so which is fine. So if I call it, have we actually found another bug in this, which is a great example of testing. So we call the transaction 1, which it passed. Okay. When we call it a second time, what actually happens on the second time? Now that shouldn't have caused that to fail. Interesting if it did. No, that passed. Interesting. So that passed, therefore that should have failed. And this should fail. No, it passed. What the hell? That can't have passed, because that should have hit that, which would have resulted in that. Oh yes, I removed the console.log for the actual error that was being caught. So let's just roll that back a bit. Let's try that again. Now hopefully this should have failed, but with an actual error this time. No, that wasn't the cause of the failure. Let's see, was this the cause of the failure? So that was the signing of the transaction. Again, not the cause of the failure. This has got to be the cause of the failure. This can't be passing every time. There we go. Right, okay. The second call to sign wallet was resulting in a secondary failure. So what the hell was that cause of the failure? Unfortunately, it's not giving me any much more insight into why that was failing. Okay, he's already signed the contract. It's commented out, so therefore that shouldn't have been an issue. The creator cannot sign this, which is correct. That is not the creator of the withdrawal. And the require the transaction form. So the transaction must have existed. It can't have invoked anything else. It can't have tried to delete. Yes, it possibly could have. I think it was the delete that has actually caused this to fail. The thing that we actually addressed and fixed. Let's have a quick look. Yes, it was the delete. There's a great way of debugging there. So what is the reason there? So the length has got to be above 0. It's got to have found the transaction within the replace. Let's just try and comment out bits of the delete which we believe may have caused it to fail. So at this point we're stating that the replace was never found. So the pending transaction was never found. Which it should have been added when pending transaction should have push transaction ID. So the pending transactions would have equaled the replace, and then the delete would have occurred. Let's just try to check to see 100% that that was the cause of the failure. Be interesting to see if it was. Yes, it is. So for some reason, now when we add the replace is equal to 1, so it does get set to 1. 1 is equal to replace if the pending transaction, there we go, we've found the bug. The pending transaction was always set to 0, so there we have it. We have found another bug. So therefore now it should find it because it was only ever looking at the first index of the pending transactions. This is what I mean about testing. It's amazing actually what you will find from just writing tests. So there we go. We can now run that again. Hopefully this will now actually fail as we'd expect it to. Because we need it to fail this time. There we go. It's actually failed. Now we know it was because of that, and that means if we now put the requirement back in, it should now pass. And there we go. I'm honestly happy that I found this many bugs in the contract, just purely off the basis it shows the importance of this level of testing. And there we have it. And that is the final test I'm going to do for this. Obviously, there's a lot more positive and negative tests you can do around this to actually test other criteria. You'd leave plenty of comments if you're doing the auditing. Make a note there that this needed to be set to 0. Make a note there that you should always assert. You should always make sure you've got your assertions in place to check that these things have been correctly matched. And actually, that should probably be a require, not an assertion. An assertion is basically I see a requirement meaning something that has to have been set before entering this condition. Before entering this sort of like condition statement or passing this point. An assertion is something that should have been processed as part of the, let's say, the function call and so forth, but obviously everyone has their own interpretations of how they should use these sort of revert transaction mechanisms. You'd go through and obviously you'd pick up on the security vulnerabilities of highlighting that sort of like for that notify callback. You'd highlight the security vulnerabilities of this deletion, also of this negative decrementing index on the array. You'd also go through, highlight the various things you found bug-wise, like all and so forth. And this is, if I was going to audit a contract, this is the extent I take it to. I know this is a long tutorial today. This is quite an elongated process, but I wanted to take you into sort of my mindset when I'm writing these things. I do apologize about the whole sort of thing, trying to look up the send the weed to the contract thing before. I probably should have prepped it a little bit more for that. I apologize. That is pretty much where I'm going to leave it today. I'm going to post all this code on GitHub so you can actually have a look at these function calls that I've made. It's very simple if you actually want to test any of this. It's simply a case of just opening up the open your window. Well, this will work in Linux, Windows, or Mac. It doesn't matter which one you're using because the npm commands are identical. Obviously, I'm running the test RPC. I'm using Truffle. I'm using Atom. You could probably do a lot of this testing within Remix as well, but obviously you'd have to write the tests a bit more granular and probably run them manually. Other than that, I do hope you found this testing and this whole sort of tutorial today useful. I feel like, honestly, if you're going to take anything from my tutorials, this would be the most valuable one when deploying something, any financial system. You should take it to this degree, and to be honest, you should take it further. If you were deploying this as a financial system, literally there should be so many tests around each function, and every single one of them should pass. You should sit there and read the logic over and over and over again to understand, because obviously if I was testing that with just one pending transaction, which I was planning to, because I was going to delete one then add one, I would never have found that. So you want to add in so many test conditions around that. Now, if you have found this tutorial useful today, I know it was a very long one, give it a thumbs up. Feel free to ask any questions, leave any comments in the comment box down below. If you would like to stay up to date with all the tutorials I plan to produce in the future, hit the subscribe button. I have a plan to now look at integrating sort of Solidity contracts with a combination of the MetaMask as well as sort of like a very basic web application. I just wanted to get this one out of the way because I felt like it was a big one that I needed to address. But other than that, I hope you found this useful, and I will catch you next time.